I'm Jason Harmon, and this is API Intersection, where you'll get insights from experienced API practitioners to learn best practices on things like API design, governance, identity, auth, versioning, and more. Welcome back to API Intersection. As always, I'm your host, Jason Harmon, CTO from Stoplight. It's been a little bit since I've said the phrase. Today we're going to do something a little different because I felt like I was beating it to death. But we really are doing something in 2+ years of the podcast we really haven't gotten into. I think we talk a lot about kind of REST and GraphQL and all these sort of synchronous APIs. Sometimes we talk about event-driven stuff. But today we're going to really get into kind of real-time and sort of streaming protocol stuff with quite the expert on the subject, Mr. Varun Singh. Varun, thanks for joining us.
Thank you. Thank you for inviting me, Jason.
Absolutely. Varun had kind of come to us, talking about coming on, and it was a real easy one to say yes to when we kind of looked. And he's got 12 IETF and W3C specifications, numerous patents. So when it comes to kind of real-time streaming, I think we got the guy here. So Varun, tell us a little bit about kind of your journey in this streaming stuff and what put you in your current role as Chief Product and Technology Officer at Daily.
Thank you very much. And yeah, it's been a journey. I started, about 20 years ago, straight out of school, working for a semiconductor company. And at that time, the whole rage was megapixel cameras. If you remember, like cameras, like phones became smartphones. Smartphones carried cameras. People started to take pictures, and that was juxtapositioned by Web 2.0, like emerging in the same period. I used to work for a company called ST Microelectronics, and then at Nokia. In both of those roles, I was working on cameras and the camera hardware and the software that goes with it. That's how I got into the space. And my background before that was like communications. I came from an electrical engineering background and such. As you know, historically, like 15 years ago, like we had this issue with Nokia being like outcompeted by Apple and such. So at that time, I kind of left the industry to go pursue a PhD. And I started to work on real-time communications because that was the evolution of like taking cameras from like taking still pictures and recording and storing it locally on your device to like live streaming it or like communicating with another person across the internet. So things like Skype. What really changed like 15 years ago was the insight that we've been building real-time communications in silos. So you had the Ciscos, you had the Skypes, you had the Microsoft Messengers. They were all building these stacks independently, trying to solve the same problem repeatedly. And people envisioned that if Web 2.0 had to like achieve its full success, it would have to be able to like work with these protocols so that anyone could build. Like right now we're using Zencaster, like the fact that we're able to like communicate, and a product like Zencaster does not have to rely on like Skype or Zoom or anything. It can actually use some of the native APIs available. So the question became like, what is the big gap between like these siloed solutions and how to make it accessible through APIs? So that was the work that happened 10 years ago. And that's why the IETF documents and the W3C specifications came out. Like the industry got together, the 12 biggest companies said, okay, we've solved these problems repeatedly by ourselves, of course, with cross-pollination. How do we make it accessible? I eventually graduated with my PhD around the same time when these protocols came to light. I built a company called CallStats.io. You can think of it as like analytics for real-time communication. So just like Google Analytics is for web, CallStats is for real-time. And I ran that business for 7-8 years. Eventually, we exited just before the pandemic, so maybe not the best timing. We've been trying to grow this product for 5, 6, 7 years. And if you're venture backed, there's a big emphasis to actually like keep doing triple, double. We did a couple of triples and doubles, but at some point we flattened out because the market kind of matured and we couldn't see it grow faster. And then the pandemic happened and like everything grew. That brought me to my current role at Daily. Daily was a customer of CallStats for several years, but because of the pandemic, it fueled its growth. And Daily is basically an API for real time communication for the widest set of use cases that you want to build on video. And lastly, it's a third gen iteration. So the first gen was 10 years ago when real time communications first appeared. There were a bunch of companies that started then 5 years later, a second gen of companies, and then the third gen, which is Daily. And I think the big difference between the third and the first gen was like developer tools. Uh, 10 years ago, there was no React, there was no React Native. Like people were writing vanilla JS. So the type of APIs you built for that period of time versus today, where you have Vercel, you have Next.js, you have like React Native, you have Android, iOS. You want to like be able to satisfy all these things, and people want to use. If you're in the React world, you want to use components, hooks, all that stuff, or use the lower level API, which is like directly. So as a product company which builds APIs, we have to satisfy like a slew of things depending on if you're basically no code versus like, oh, I want to like control every aspect of my experience, both or both ends of the spectrum. So that's how I got into my current role.
Very cool kind of progression. I like that connection of like how videos changed as sort of the mobile world and the web has changed. But full disclosure here, I am not a video or streaming guy. I don't know much about this. So I'm going to ask you like a million dumb questions today. And my hunch is we have a lot of
That's
listeners
perfectly
in the same
fine.
boat. So I guess the first one is: are we talking about like the stuff that when I watch Netflix or YouTube? Is it that, or is it Zoom, or is it what kind of sort of streaming things are you talking about?
That's a good question. And I think the way we think about it, there is canned media or stored media, which is what Netflix is all about. Like, you're watching a show, the show exists somewhere. They can actually use things like distribution network CDNs to kind of push it as close to the edge so that you as an end user get a great performance. That's one aspect, and that's what we call stored media. It's been happening for almost 30 years now. The technologies improve vastly that you can like actually do very quick uh, like changes in quality which are not perceivable to the human, um, even if you have a network issue. So that's more or less solved problem. There are a bunch of companies that try to do that. A lot of the magic is in the content delivery network, so video content delivery networks. The second one, which is live streaming. So, we just had the NHL playoffs and the NBA playoffs this last week. And if you're watching something like that, I think there the biggest thing is that it can't be stored because you're watching it. And then the question is, how far behind real time can you be? It can't be really, really live. Like it can be, but like most often it's like a couple of seconds behind, mainly because they want to, for legal reasons, but also they want to distribute it widely. That's called live streaming. Uh, Typically today, most of the technology is 5 seconds behind. Um, so basically, if a goal happens, you can see it on your screen 5 to 10, 15 seconds behind real time. The main notion there is that you shouldn't be screaming goal before your neighbor does, or vice versa. Your neighbor shouldn't be screaming goal or a score before you do. So that's like the biggest challenge in that framework. And the third one, which is like real time communications, where you're seeing something live. And what we've seen over the last 10 years is that we started with two people in a call, like just like Skype and whatever came after. Two people having a conversation, and then people said, "Oh, we want to use it in a work setting. Can we have 5 or 6 people in a call?" During the pandemic, that became town halls, 15 people, 30 people, and now we routinely see like 10 people in a call. The question now becomes like all these use cases like the live streaming before that I talked about, where there are millions of people watching this like the game. Can you do that in real time? Can we use the protocols that we use for like having real time communication? And here we're talking about 200 milliseconds delay, right? Like between you and I, it would be probably like tens of milliseconds, because we're roughly in the same part of the world. But max, like if you're halfway around the world, a speed of light, you can't go faster than speed of light, and cables and all those things. So you're about 300, 400 milliseconds behind. But still good for interactivity in case you want to raise your hand and, like if you're having a big town hall, 10,000 people watching the CEO speak and someone wants to ask a question, you should be able to raise your hand, get onto the floor through the green room or whatever, and ask the question live and then hear the answer live. And those are the use cases that a lot of people are aspiring for. And I think the blurry lines between these three use cases, like the live stream, the canned media, the live streaming, and real-time communications, are becoming blurred. People want to use not three different protocols or three different technologies or three different vendors to do it. People want to roughly use this one API, one vendor. And does it matter? Should it matter that I'm connected to you in real time, or I'm connected to like a sporting event, and or like getting something from Netflix? Like basically, the API should be I'm playing video. The source could be live or real time or canned.
Yeah, I was going to ask that too. Looking through some of like your IETF work on these things, I saw a lot of like RTP, WebRTC, things like this. In these kind of categories, like what are sort of the common protocols and where do you see that things are perhaps converging?
It's a good question, and I think everything that is old becomes new again. So RTP is like 30 years old technology, and it started for broadcast or multicast. And if you know your IP addresses, there's like a set of multicast addresses at the end, which are not accessible mostly because like the ISPs don't allow like transmission. Like if you're on Verizon will not allow like a multicast beyond its boundary, for security reasons, but also they don't want to send media outside and like then get media from outside. So it started for multicast, and a lot of the decisions we made for RTP were based on multicast. However, like by 2000, so this is 1992 when they built the protocol. By 2001, 2002, multicast was kind of dead. It was only used in IPTV. So your cable TV network is probably still using broadcast to like send you cable TV over cable, but it's coming directly from your provider, and that's typically the person you bought the internet from anyway. So that still exists and still continues. And when I talked about earlier, like MSN or Yahoo or like all these messengers from 20 years ago, they all actually used RTP, including Skype. At some point, started to use RTP because that's what all the engineers knew, right? Like if you move from one company to another, you can't like learn a new protocol. Like it'll just take you like 2 years before you're like competent in that new thing, and you're just relearning something. So like RTP is like the standard. What WebRTC was, and like people talk about WebRTC both as a protocol and as an API, and they use them interchangeably. So there are two aspects of WebRTC. One is the API, which was standardized and implemented by the browsers. Of course, the browser API is called libWebRTC. It's inside Chromium. It's also inside like all Chromium derivatives, so Brave, Edge, Arc. All these browsers have it. And then Mozilla has their own version of WebRTC, and Safari has a somewhat different version. But the API is a standard, so it doesn't matter which browser you use, or if you take that library and recompile it into Android and iOS, you still have like the same APIs because the web APIs have a corresponding C++ layer, so you can call these APIs anywhere. And then APIs in this case are not sufficient because there's a protocol that like sends the media over the internet. So those are so that's the WebRTC protocols. And WebRTC protocols are actually all old protocols. As I said before, all these companies had Cisco, Skype had their versions of their product, and they were all slightly different versions of RTP with extensions. If you're doing two cameras, one camera, no one uses the standard process or the standard protocols because there's always something that they need to do extra. Either their codecs are different, like H.264, H.265. So back in 2010, when we decided to work on this, people realized that there was a lot of competence across the industry, but no one had a standardized way of doing certain things. So the whole thing about WebRTC protocols is just the whole industry coming together and saying like these variants and these extensions of the protocols will do these things. And then that meant like, had Cisco, WebEx, Zoom, all of these folks using roughly the same kind of things behind the scenes.
Got it. Yeah, it's funny as I was kind of skimming around trying to not sound like a total idiot on this subject and know vaguely what you're talking about. I was getting flashbacks of like Real Player and some of these old things that I
Oh
remember
yeah,
using all this stuff. Yeah.
Real Player is a good example of like old things becoming new. So there was a thing in Real Player called RTSP, Real Time Streaming Protocol, and it uses RTP underneath. WebRTC uses RTP underneath. So it's RTP by itself as a unit block is quite versatile. Of course, it was built for a different time. So, and for old things becoming new, now there's a whole new initiative called Media over Quick. And if you, Quick is like this new protocol that is over UDP instead of TCP. And HTTP 3 uses Quick, for example, and there's a whole reason why we use UDP now over instead of TCP for all these things. So if people are reimagining the world of Real Player, which actually had real-time streaming over UDP, to say, oh, can we bring back these old things 20 years later? Uh, and WebRTC already does UDP. So can we marry this whole world where the almost all of the web would work, HTTP and real time, and everything would work over UDP underneath. Um, Somewhat a demise for TCP, but you know, no demise is complete.
Yeah,
It takes
I
20
love
years
going
to.
back and watching like computer scientists from like the 60s, 70s talk about ideas and things they had, and you realize there's nothing new. Everything's reinvention. Everyone thought of everything a long time ago. It's just taken a while for things to mature, and mature usually just means going through two or three lifespans of reiterating on the same thing. So sounds familiar from my world.
Yeah, and although I would say what's changed from the 60s is how easy it has become to like build these
Oh, for
things.
sure. For sure. Yeah, developers are super powered now. Spoiled. I remember, back in the 90s, man, like you want to learn something, you got to buy a book, you got to buy software. Now everything's open source, freely documented. Wonderful.
Languages
So
were
that means I
difficult.
probably have no excuse for not knowing this video stuff, but I just never had a job doing it.
Yeah.
I guess what are, as things are kind of coming together these days and perhaps converging a bit, like what do you see as kind of the big challenges? I mean, I look at like these reports saying like 80% of the internet's traffic is video streaming and stuff like this, that it's just like there's got to be crazy challenges associated with that.
Yeah, I think 10 years ago it was all about streaming. The things like Netflix and YouTube were like the 80%. The pandemic shifted that to, like the number of video calls we are on every day. Like when we were in the office or even like before, like people did like maybe a few calls a day. Some people did one a week or further apart, but we're now doing, everyone's doing at least one or more calls per day. So the real time videos is more prevalent now. I'm going to go back to the three use cases: the canned media, live streaming, and the real time. I think what the biggest challenge is that people are thinking of newer experiences, where they're thinking about like, hey, you and I are having this interaction while there could be 100,000 people watching this, and people think of Twitch being like one way to do this. And people are like, oh, how do I bring Twitch to my community? I don't necessarily want to use Twitch, but I want to like have my experience, which does roughly the same thing. But I also want like people to have interactivity, like people be able to clap or like do emotions. And if you just look at the announcement from WWDC last week, like Apple came out with like screen sharing, layered screen sharing. Like you have video, you have your slides, you can go back and forth between that. You have your TV, Apple TV, and you can use your camera like as a device, and then you can do share play. So like there are so many such use cases that people are thinking about, and Vision Pro is coming, and people talk about the metaverse at length for both home use cases. And so video is just going to, everyone's going to have videos. And this is outside of like all the Ring devices that we have, or like the doorbells and like the surveillance stuff that's happening, pet cameras and such. So video is just like immense, and depending on what slew of use cases you look at, you just see video emerge more and more across this. So the biggest challenge is like if I'm thinking of like a use case that goes beyond just the solitary. So like if I'm just doing surveillance and a doorbell, you say, okay, that's maybe one use case. But suddenly you say like, I ring the doorbell, you're not at home, you're at work, you have to open the door. Now you want to have this interaction. Now it's not just like recording surveillance, but it's also like a real-time interaction. You want sometimes now with AI and ML, people like, hey, I want to like be able to detect someone passing by, do a bunch of alerts, send a thing, maybe patch the user in to talk to this person who may not have rung the bell as yet, right? So in that case, you're thinking of these as three different technologies or two different technologies. Our thesis is that it should be one technology. It could be it could be several vendor, like it shouldn't be several vendors, but like the vendors need to be thinking about like, how do I solve this problem without actually having the developer to think too much about it. So when I said earlier, so just like a call back to one API, basically saying it shouldn't matter I'm talking to, like a server recording, or like basically an ML algorithm which like finds the thing, then triggers a communication, or you press the bell to like get the person into the call. All of that, like from an engineering perspective, should be hidden. um, and that's how we get accelerated into like people building more robust unique use cases, because if everyone's trying to solve like what I call protocol shenanigans, like you go from one protocol to another, then they don't always work together, then you spend a lot of time debugging and trying to like make them kind of massage them into place. And that can be the same with multiple vendors. You're like, hey, this thing has a different state, it gets triggered at a different point, the state machines don't match, how do I make the state machines match so that I can make them work together? um, I think those are the biggest challenges. And we have a perception that having very simple APIs that solves all these problems under the hood kind of takes away some of that mental gymnastics that you might have to do to like kind of get these things to work together.
Yeah, it was easy enough to see in kind of surveying this stuff. I mean, even just video encoding formats, it's mind boggling how many of these things there are now. Like, I guess it's just like a topic I hadn't paid attention to in a long time. I was curious though, in the more kind of synchronous and like event driven things, there's always this challenge of how do you kind of design how these things are going to work or look at scale when you have lots and lots of them so that people can find the right thing, understand how to use it. Are there sort of common issues like that in the streaming world? I mean, it's kind of weird because it's like you're basically just grabbing whatever video comes at you and throw it the other way in some sense. But when you think about like I'm starting from scratch, providing a developer experience for integrating with these things, kind of what are the design challenges?
Yeah, if you come from an HTTP model of thinking, it's slightly different, because like in HTTP, the resource needs to be like replicated in many places, right? Like you basically say, oh, someone, let's say even in the case of Facebook messages or whatever, like the thing is like someone writes a message, you push it to the web server replicates it in one or more places, in databases and caches, so many places, and then someone who's reading it like pulls it. And the design problem there is like how quickly are you like ingesting this data, and how quickly are you like exposing this information like a new message, right? So like you have pub sub like as a design parameter, where you're like, I'm publishing information, I'm subscribing to this information, and if the system knows that there is a live subscription on this publish, then there's a fast track to like kind of make this message go faster to that subscription while you're still also putting it to disk. um, there's a lot of HTTP stuff that you can use for like standard messages if you're like thinking about data. Unfortunately, that same thing for real time is a work in progress. So what we call selective forwarding units, they've existed for about like 10-12 years. It started with like there used to be something called multi-control units, MCUs, and SFUs. Now the thing there was like, if you remember when we had offices and room systems, like you went to a room and you had a video system there, you switched it on, saw people on television. Typically they would composite the video. So like even if there were 5 people in the video, they would like, there was some server in the cloud that would composite them together, like small, big, whatever, whoever is speaking someone would like the algorithm would control it, but you would only get one stream. So even if there were 5 people on the video, uh, the compositing in the cloud was doing that, and that made sense. Like if you're Cisco and you're selling servers, it's your job to like kind of sell you like it made like you could buy a heavier, more expensive server which would do like 20 people or 40 people. So like there was business need, and Cisco was in the business of selling servers, so it didn't like that was what they did until like 10 years ago when selective forwarding units and like as you're scaling you have 20 people, you can't actually composite it anymore, right? Like it's too much computing resources on the cloud and someone has to pay for it. So people realized that instead of like having very large servers, what if we distributed these servers across the world and they selectively forward? So like if you are on a big call, let's say a Peloton, right? Like that's a very good example. Like there's a trainer, you're looking at the trainer, but also a group of cohort of friends who are like who are doing this exercise together. But there are also like 50 other people who you don't know who are on the call. So like it becomes like I want to watch the trainer. I want to have a synchronous live communication with my friends, which is private. We don't want the trainer to hear that. But then there's also like the 40 other people that I want to see in small, like, so you basically have these three modalities now that's happening. One, follow the trainer, comment with your friends, and then watch the rest of the class. Now, in this cases, you would like think about which ones can be delayed. What are the latency guarantees for each subset? And that's what the selective forwarding unit would do. So basically, the end points would have more control. I, as an end user who's on the bike, can decide who I want to watch at what priority. And you kind of move the logic away from the server side, uh, largely to the endpoints because endpoints can subscribe. And then you need that magic, right? Like if I have a bad connection, if I can't carry all those 60 streams, which streams should I deprioritize? Which streams should I see in high resolution at high frame rate? Which ones can I do at low resolution, lower frame rate? Which ones can I turn off, right? Like I can turn off the class if I don't have enough bandwidth. And I just want to listen, like, and if I'm really low, then I should just see the trainer. And if I can't see the trainer, then I should either listen to the trainer or I should just see the trainer and turn off. And like some of that magic can happen on the cloud. So basically, for this, you can't use something off the shelf. There's some open source things, of course, you can build on top of, but uh, but some of these things, like if you talk about mesh SFUs, which is like you have a SFU and then how do you scale? Like you can horizontally scale something or you can vertically scale something. And typically, if you want to get 100,000 people watching some stream simultaneously, you'll horizontally scale it, right? So that is like the magic that we bring is we have something called mesh SFU, which allows you to like horizontally. So we horizontally scale so that you don't have to worry about like you have 10 people in a call or 100,000. We will figure out how to do that. We give you enough APIs to express like what are the priority levels. We figure out how much bandwidth our servers figure out how much bandwidth you have so that we can downstream the appropriate amount of data so that you can have a good experience. Developers can say like, in the worst case, what do they want? Do they prefer video over audio? Um, so in the worst case, then we can use their input as guidance so that the servers can decide what to do in those circumstances.
Yeah, all this stuff makes my head hurt. Which I noted that you've also are working on a book on kind of this live streaming type tech stuff. You want to tell us a little bit about that?
Yeah, we're cooperating with the Dummies franchise. So there's a Dummies for interactive live streaming that will come later this summer. The idea here was to like put together these three aspects, like uh, the different various use cases people have, both for live streaming and real time. That's one part of the book. The second part is the protocol shenanigans. Like there's so many protocols. They're all 4-letter acronyms, and you have to learn so much before. How do you like reconcile all of that into like one holistic viewpoint? So mental model for that. And thirdly, like what would the API look like? So we've had the product out for over 2 years now. So writing this book is a point in time to say that this is not really that complex. The use case have emerged, and people are thinking about this experience more widely than people know. And there are simpler ways of doing this. So one mental model, one API, and if you care about the underpinnings, it's one protocol that drives all of this.
So normally this is the part of the show where I ask guests, where do you think, if you had to point someone in the right direction on where to get started, where would they go? My hunch is you might just answer read the book, but I'll go ahead and throw it out there. For someone just getting going in this, what's your advice?
Yeah, I mean, we have really good blog posts on Daily Co that you can go and find. So you type ILS, interactive live streaming, Daily Co, you'll find it. I think docs.daily.co is like a really good starting point for this. If you're really curious like about the underpinnings of this, you should wait for the book to come out. It explains in like good graphics for dummies, for example. So like, we've tried to like go with that idea that make it accessible to people who are interacting with the technology for the first time. And it should be out in the next 60 days. So
Oh, cool. So probably by the time this goes to air.
yeah.
Well, I identify with feeling like a dummy today on this subject. So I think you might have picked the right category of book. But thank you so much for kind of giving us some insight to this stuff. And I guess for folks who kind of want to learn more, hear from you more, I think you already kind of mentioned the daily blog. Are there other places people should look to follow you?
Oh, follow us on Twitter. Follow us on Mastodon. We're on all socials, including LinkedIn. You should type daily.co and you should find us. Or Daily
Very
HQ.
cool. Thanks again for joining us, Varun.
Thank you, Jason. Thanks a lot for inviting me and having this conversation. It's been fun.
Thanks for listening. If you have a question you want to ask, look in the description of whichever platform you're viewing or listening on, and there should be a link there so you can go submit a question, and we'll do our best to find out the right answer for you.
API Intersection podcast listeners are invited to sign up for Stoplight and save up to $650. Use the code INTERSECTION10 to get 10% off a new subscription to Stoplight Platform Starter or Pro. Take a look at this episode's description for more details.